Okay, this is going to be an introduction to Autosync, which is a program designed to rectify historic aerial imagery or non-rectified imagery to a known reference image. Autosync is a component of ERDAS Imagine, and this is the actual ERDAS Imagine opening screen with its ribbon interface. You'll see that it has a menu bar across the top. Currently is the toolbox selection, and on the toolbox selection is the Autosync workstation option. So without wasting any time here, we'll go through and open up Autosync. First thing you're prompted with is whether you want to create a new project or whether you want to use an existing project. In this case, I've prepared some imagery for this task, and I'll create a new project and show you how to load that imagery. Right, once we've selected new project, we can either georeference or age match an image, we can calibrate or resample it, and we have some options as to where we put things. In this case, we go to georeference. First thing we need to tell the program is where to store its own operational file, or its LAP file. So what we'll do is we'll just surf to where I've created this data. Now I've created a folder in our C data folder called Async. I've created an authors folder, raw images folder, and a reference image folder. In the reference, I'll create our Autosync project. We'll call it Boomai, because this is the 100,000 map sheet name on which the area is sitting. Now we've created the lap file. We can calibrate or we can resample. Calibration means taking the original input image, correcting it, and then rewriting it to an output file. Basically the same image. Resampling takes the original source image and recreates a new output file which is rectified, so we're going to keep it on resample. Our output directory is C data, so what we'll do is we'll change that to our authors folder on our dataset. So it's now C data Async authors. We'll leave underscore output as the suffix on our rectified file names. We'll generate a sample report, a summary report as a HTML file, which is a standard. Okay, now we've created our basic file structure for the job. To be able to rectify images, you need a reference image to align them to, and you need an elevation model to be able to assess the height above ground of the image at each point. So the first thing we'll do is we'll add our input images. The easiest way is to right click on the input image and use the add input image option. We'll go to the raw folder into which I have the data stored. Now IMG is set as the default on my computer, but we'll just set this to all raster formats. We'll pick 2 or 3 of these images eventually, and we'll load those because they're, as you can see, JP2 files, which is why they weren't showing up originally. Okay, so the software actually opens up those 3 files and places the image of the first one in this window array. We'll now open the reference image, which I've already set up into the reference folder. It's an ECW file, so we'll use that one there, which is the Boomai 1 to 100,000 scale map sheet, and you'll see that that will appear in the right hand side in its entirety in this top minimum zoom window, and then the area covered by the selection cursor is shown in the bottom large window. The area covered by that selection is shown in the top maximum zoom window, and it's the same on the left hand side for the reference image, for the input image, sorry. Now that we've actually pulled in the input and reference images, we need to set up some other parameters for the project, and the way we do that is to go to the process, project properties selection. What I'm thinking specifically is that I need to open up my DEM. Now it's a bit dodgy because you have to select off the file, back onto the file to actually be able to select the file. Don't ask me why. Okay, we'll go back to our C. Boomai C data, Boomai reference, we'll reselect our all raster file types. There's our DEM, which is a shuttle radar image that's been clipped to the actual area of the Boom 100,000 sheet. It is actually a DEM with elevation information, and Autosync's not recognising it as such. We'll select yes to use this so-called undefined reference information. Okay, so now we've selected our DEM. We can select to output the data in the same reference system as the reference image, which is in this case transverse Mercator, GRS 80 is the spheroid, GDA 94 ICSM is the actual datum. Let's just change that to show you how to do it. We'll select the standard Australian projection of GDA 94 MGA 55, which is the area covered by this photo, and you'll see that it's changed that to GDA 94 in this particular dialog. Our output, we have our resampling settings, which is we can just accept the defaults for this particular job, and we'll set the output file names. Instead of making them JP2s, we'll make them Imagine images, because it tends to process a bit quicker to produce an output IMG. They can always be converted later on. We have it set to C data orthos as being the output folder, and we have the underscore output file name as we previously specified. So now we've basically set up our input images, our reference image, and our digital elevation model. We've told the program where we want to put our files and our outputs, so we'll just accept that. We'll do a quick save to make sure that all that information is updated in the file. Okay, at this point, before we go on to the intricacies of the use of the program, I'll just stop it at that point and begin again in a subsequent tutorial.